Hello guys, my voice is audible to you?
Yes, sir.
Okay. So in the last lecture, we missed one part which I need to discuss. So in case of uniformly accelerated motion, we talk about the displacement in the displacement in the nth second of journey. So nth second means if you have traveled for let's say 10 seconds, then how much you travel in the 10th of the second. So nth means if n is the time interval in seconds. So let's say this is how much you travel in the n seconds. We write Sn. Sn means the total journey which you travel in n seconds. So symbolically, if this is the journey which you have traveled in the 1 second before up to n minus 1 second, this is called Sn minus 1. Then this is called the journey travel in the nth second, the last second. Okay. So when I say nth, it means out of n second, what you travel in the last 1 second of that n second. Okay. And we assume the uniformly accelerated motion. So how to get the nth second answer? What we should write here? S nth equals to, guys, how much?
Sn minus Sn
Sn
minus
minus Sn minus 1, right? And what is the meaning of Sn? The displacement in the n second in total. So here the time is n. So if you use the formula, what you like? Ut plus, now t is here n. Do remember, half at square. So this is the Sn. Similarly, what we should write for Sn minus 1? Tell me, guys.
Un minus 1 plus half an minus 1 whole square.
Very good. Now it is easy for you to rearrange and simplify. So if you rearrange and simplify, how much you'll get? Can you do the simplification and tell me the answer? Now you should not get confused with Snth and Sn. So Snth is the last second out of n second, and
Sir, I'm getting 2an square minus 2an minus 2d plus a by 2.
Yeah, so I think you have expanded. Okay. Anyway, so if after simplification, what is the u term? U term is how much? Simply you have to subtract, right? It's not very big deal. And once you subtract, you get a simple answer. How difficult is to subtract? I don't know. Tell me, Shreya and Rugved, what is the answer you're getting?
U minus 2an plus a.
U minus or plus?
Plus 2an minus a.
2an minus a.
Huh.
Check 1 second. Have you taken care of half 1 by 2?
The
Just check.
2 will
Okay.
not come.
Yeah. So what will come?
U plus an minus a by 2.
Correct. So you can take a by 2 common. The better way of writing is you get a by 2 into 2n minus 1, right? This is what you get. You can take a by 2 common, you get n square minus n minus 1 whole square. So we know the formula of a square minus b square, which is a plus b into a minus b. Correct? So if you subtract the u term, you get only u. And then you can take a by 2 common, you get n square minus n minus 1 whole square. And that will give you this answer, which is same as what you said. So the displacement in the last second of journey is given by u plus a by 2 into 2n minus 1. I hope this is clear. Okay. Now, if you start from rest, if journey or if u is so if a particle is start from rest, then u becomes 0. In that case, the s nf becomes really easy. So sometimes they ask that okay, a particle start from rest, then find the distance traveled in the third is to fifth second. So you can use the formula, the second one a by 2. So a by 2 gets cancelled out. So you can take the ratio. If u is 0, then s third upon s fifth will be how much? 2 into 3 minus 1 upon 2 into 5 minus 1, right? Which is equals to. So the displacement in the third second since beginning and displacement in the fifth second from the beginning, the ratio comes out to be 5:9. Okay, is this clear?
Yes.
So let's do one problem in which u is not 0. So this problem was basically when u is 0. Okay, so let's write a question. A particle is moving with uniform acceleration if the displacement in the third second is 7 meter, fifth second is 15 meter, then find the displacement in seventh second. Now, what you need to be careful here that nothing is said about the initial velocity. So, what you will do? Will you assume it or will you ignore it?
So is the answer 10 meters?
Okay. What is the value of u you are getting? U is how much? How much you're getting u and a?
So I got A as 4.
A as 4, okay. And U as?
So 1 second, I think I went wrong.
Yeah, I think you haven't taken U, right?
Yeah,
Yeah,
forgot.
that's why, that's why. You have to believe that a U is there. I mean, see, nothing is said about U. If numerically U turns out to be 0, that's okay. After solving. See, U and A are two variables and you have two equations given. So at third second and at fifth second, the displacements are given. S is given for n equals to 3 and n equals to 5.
Sir, is the answer 23?
Maybe that seems to be logical. So S3 or third is 7 meter given to you, and S fifth is given. So this we can write as U plus A by 2, 2 into 3 minus 1, right? U plus A by 2. So we have two equations and two unknowns, so we can solve. So U plus A by 2 into 5. And U plus 9 by 2 into A. We can subtract, okay? Like this, 2 minus 1. 1. So 2 minus 1 implies 8 equals to 2A. A turns out to be 4, right?
Yes, sir.
Very good. I think Prashansa also got the A4, right?
Yes.
And then you can substitute A value in any of the equation to get U, right? So U plus A by 2, which is 2 times 5 is 10 equals to 7. So U turns out to be minus 3, which means the initial direction of velocity was opposite to the acceleration. So the displacement in the 7th second will be U plus A by 2 into 2 into 10 minus 1, which is minus 3 plus A by 2 is 2 and 14 is 30. So 23 is the right answer. Very good. This is what you got, Siddhant, right?
Yes, sir.
Very good.
So I also got one.
You got the idea? No, right?
Yeah, I got the answer. It's 23.
Very good. Rugved, you have doubt?
No.
Okay. So these are some very simple and question in which you have to use the linear question and then solve it. So I would say from uniformly accelerated motion, we'll stop it here. We'll do the rest of the question of uniformly accelerated motion using graphical solution. So now we'll move towards something called graph. So what do you mean by graph? If I ask you, explain graph. What is graph, guys? Do you really realize the graph? When I say graph, do you realize it? So before you realize something, let's do an experiment. So what you need to do is take your notebook, go to the last page of the notebook. I'm imagining this is the last page of your notebook. Then you move your pen up and down like this. Just move like this and pull your book from the left side. So using the right hand, move your pen up and down and just pull the notebook from the left and let me know what you're getting. Are you getting a straight line or something else?
So we're getting a curve.
Curve, very good. So what we need to realize that what curve is representing is the coordinate of your tip of the pen with respect to time, because as you were pulling, the time was changing. So as time is progressing, the tip is moving up and down, but on a time scale, it is moving forward. And that is why you're not getting a straight line, rather you're getting a curve. So most of the graph that we are going to plot, in fact, the majority of graph will be time dependent graph. Okay. And therefore it will be confusing for you to understand that the time dependence graph, how to read such time dependence graph. So the motion is still happening in one particular direction because we are talking about the one dimension motion. But the graph will look on a 2D paper. So graph should be interpreted by looking towards the y-axis. Okay, so I'll let you know what is the meaning of that. So what is the meaning of graph? It is a geometrical picture. So graph here we are talking about the 2D graph, okay, not so graph in a plane, and we are trying to understand the meaning of it. So it is a geometrical picture which relates to physical quantities in which if one is known, then other can be figured out. So technically, a graph is representing a relationship between two variables. Okay, so mathematically speaking, we talk about two variables. So mathematically speaking, a graph is a relation between two variables. One of the variable is called, I have discussed this in mathematical tools, is called independent variable, which is generally plotted. Now this is not a like a thumb rule, but it is like convention plotted on the x-axis, and the dependent is plotted on the y-axis. So graph always talks about the dependence of two variables. So one is called the independent variable, other is called the dependent variable. And the dependent we plot on the y-axis and the independent we plot on the x-axis. Time is called universal independent variable. So what we need to remember, the time is universal independent variable. So we always plot time on the x-axis. Now we need to learn the interpretation of graph, how to interpret a graph. So every graph will have two things. So the moment you see a graph, two things should come to your mind. One is called slope, another is called area. Only these are two elements that we need to understand or decode. Slope we know from the calculus, it is dy by dx. And slope we define for one particular point or coordinate. So you draw a tangent to the graph. And the slope means the angle this tangent makes with the positive x-axis. I hope you remember. And area by definition is called integration y dx, which means area under the graph from somewhere to somewhere. So the range of independent variable up to which you would like to find the area is called the limit of integration. And this can be integrated because y is dependent on x, or y is a function of x. So definitely in every graph, we look for these two things, slope and area. And then we'll try to decode as per the definition that we have already defined in the previous lecture. Okay. So to begin with, we will talk about the first graph, which is the most challenging graph for many of the students. And that is called position time graph. So if you choose one particular direction, it's called the x direction as the direction of motion. And if we have somewhere called origin, so x is the direction of motion. Okay. And then we have some object. So when I say position, it means at t equals to 0, it is not necessary that the particle or the moving object must be at origin. It could be anywhere, right? Because we are talking about the position. Position means the coordinate. So at x equals to 0, you can call this as x naught, and this is x. So when I say position time graph, then the particle can be at origin, on the right of origin, on the left of origin, everything is possible. But now we would like to plot against the time. So when such motions are plotted against the time, then the direction of motion, we make it dependent variable, and time we make independent variable because time is always independent. So the motion which I was representing on the right side, now I'm representing on the upward direction. So the y-axis will become x because that is representing the position, and this is the time axis. So you must check your position on the y-axis because position is now plotted on the y-axis. Okay. So there are three types of graph you can plot. First is called a straight line. So I may plot something like this. I may plot something like this. I may plot something like this. So we have three particles, like three athletes running on a running track. Think that way. Now, if I number the particles, the athlete one is, having the pole position in the front of everyone. So you can see who is ahead of all. Our running will start in the positive x-axis. So you are going to run towards the positive x-axis. But at the very beginning, you can see all are not starting at the same position. So who is ahead of all? Can you see the graph and tell me?
1.
1. And who is behind all?
3.
Hmm? Okay, so 3 is behind all and 1 is ahead of all. Okay. So first of all, we'll talk about the two things, the slope and the area. Let's talk about the slope. What is the meaning of slope? What is slope here? dy by dx. Always remember slope is dy by dx. But what is y here? Y is? What is y here?
X.
X. So y is x. And what is x?
dt.
dt.
Now go back to your thinking and tell me the definition. What is the dx by dt meaning? Rate of change of position is called velocity.
Velocity.
Now you need to understand that slope represents instantaneous velocity. Slope represents what? Slope represents instantaneous velocity. It is clear to all of you? Yes or no?
Yes.
Yes, sir.
Now also tell me, if you look at the graph, all graphs are represented by a straight line. What does it mean? A straight line will have slope variable or constant slope.
Constant.
So all these lines are representing what? Constant velocity or variable velocity?
Constant velocity.
Very good. So all these lines are representing accelerated motion or non-accelerated motion.
Non-accelerated.
Very good. Is this clear to all of you?
Yes, sir.
Because no matter where you plot the tangent, you will get the same slope. So a straight line is representing a constant slope. It means every line is giving you the velocity of constant value. So who is moving fastest here?
1.
Fastest means what
3,
is the meaning fastest?
So 3 not.
The 3 is
3,
fastest means the slope is maximum, which means the steepness of the line. The steeper the line, faster the man, faster the velocity. Yes or no?
Yes.
Do you all realize this? The steepness part.
Yes.
So now tell me, Rugved, who is moving fastest
3.
and slowest?
1.
1. Very good. Now, what you need to learn is that the time axis is not what you need to see. You need to only see the the x-axis, the vertical line, the y-axis. Basically, you can say here the position axis is y-axis. So motion is still happening along the x-axis, the position axis, the vertical axis. In this case, we are plotting the time dependence relation. So as time will progress, you will be here. You will be here. So you're not coming towards the right. So this is a very common misunderstanding. See, we are still moving on the y. What we are plotting is the position versus time graph, right? That's why graph is appearing on the right side. It is time dependence position. Understood? So can we say the velocity of the one is least than the two than the third?
Yes.
Okay. Second thing is we talk about chasing. Okay, chasing means when you overtake someone, right? So who will overtake whom at first? On the time axis, you can see which overtake will occur first.
3
3
overtakes
overtakes
2.
2,
Correct. So the first overtake is here. On the time axis, this is the first intersection, this is the second intersection, and this is the third intersection. So the first overtake is 3 overtakes 2 at some time t1. Then who will overtake whom? The next overtake is
3
overtakes
overtakes
1.
1,
3 overtakes 1. And then last is
2 overtakes 1,
very good. So at t equals to t1, at t equals to t1, what you can say? 3 overtakes 2, right? Am I correct? At t equals to t2, what we can say, guys? 3 overtakes what?
1.
1. And at t equals to t3, what we can say?
2 overtakes 1,
2 overtakes 1. So 3 was like most behind most person. So in the actual race also, you must have heard about the pole position. If you see that race track, so every track will have different radius, right? Small radius, big radius, and bigger radius as you go away from the center. And also the position of the person is not in the same line. They are actually arranged in a slant line. Okay. Have you seen the race? So on a track, the first person is here. The second will be based on the track size. So there is something called pole position. So it may be like this, maybe like this. So there is a race before the race to decide who will stand where. So that's called the pole position. And the pole position happens in case of like athlete, for motor racing, also for bike also, everything. It is clear. So looking at the graph and looking at the slope, you got the idea. Now tell me, if I take the area is what? Y dx. So area is y dx. Now tell me, is there any physical significance of x multiplying by time? If I multiply position with time, do I get something meaningful as per physics? X dt gives you what? Tell me. X dt gives you what?
So is X constant or variable?
X is the position vector. X is position and time is t. So is there any physical meaning? I'm asking. The answer is there is no physical meaning. So in the xt graph, we only talk about slope. We never talk about the area. It is clear.
Yes.
That's
Yes,
it.
sir.
See, the idea is you always check the two things and try to figure it out from the knowledge of physics that does it represent some meaningful thing? Yes or no. If it is representing nothing meaningful, nothing physical, ignore it. So we know velocity into time is called displacement, but there is nothing, there is no meaning of x into time, right? Is there any meaning of position into time? Can you recall something meaningful from your knowledge of physics? Tell me. Yes or no? Hello guys, can you tell me? Can we decide something meaningful out of this? The answer is no. So we can ignore it. Okay. So we saw the xt graph when the motion was non-accelerated, or you can say uniform motion basically. So let's talk about the xt graph for non-uniform motion. Okay. So try to see this graph. Try to interpret this two graph, and you need to know that okay, we need not to think about the area at all. So what we need to think is only slope. So the first question to you, is the slope constant? Yes or no? Okay, first thing, where we starting the journey from?
Origin.
Origin.
Origin. It means the journey has been started from the origin of the assumed coordinate system. That's correct. And tell me which graph is representing what? And I will not explain anything. You will tell me what is happening in the red graph and what is happening in the green graph.
So
Try
the
to
red graph is representing decrease in velocity
very
and
good.
green is representing increase.
So the velocity in the green at t equals to 0 is how much? What is the velocity at t equals to 0 in the green case?
0.
0. Correct. In the red case, is it 0?
Yes, 0.
No, it has
In the
a
red,
slope.
in the red at t equals to 0, velocity is 0 or non-zero? Tell me.
Non-zero.
Non-zero. Excellent. How you decide the velocity? By drawing tangent at a given instant. Can I draw a tangent to the graph, green graph at origin?
No.
No, if you try to draw, how it will look like?
A horizontal line.
Coinciding with the t-axis, right?
Yes, sir.
Yeah.
So a horizontal line represents what angle? Zero angle.
Yes, sir.
So slope of the graph is 0, which means the green graph is representing such motion which starts from rest. Do you realize this?
Yes, sir. Got it.
And as you progress, your slope will grow or decrease. So from 0, it will never decrease. So it is going to grow, isn't it?
Yes, sir.
And you can clearly see in the green graph, as you progress, the line will become steeper and steeper and steeper. Do you realize this? Can you draw 3-4 lines at different location in the progress of time and check if the slope is increasing or decreasing? Can you check?
Sir, it is increasing.
It is increasing. So the green is representing accelerated motion. Understood? Green is representing which motion?
Accelerated.
Accelerated. What about red? At t equals to 0, if you draw a tangent, how it will look like? The tangent at in the red graph at t0, is it 0? See, this is the tangent I'm drawing at origin, and you can see it's a quite steeper graph, right? So for the red line at t equals to 0, is the velocity 0?
No.
No, because the slope of xt graph represents velocity. And in fact, I can see that velocity is in fact maximum. So at origin, it is the maximum velocity, right? So maybe it is coming from somewhere behind, but we are plotting from 0 because we are taking the origin at 0. So while crossing the origin, it is having the maximum velocity. But the moment you progress ahead the origin, you can see that slope is, as the time will progress, slope will increase or decrease.
Decrease.
So the velocity magnitude is decreasing. So what kind of motion it is representing?
The acceleration.
Retardation. Retarded motion. Can you say? Or deceleration.
Retarded motion.
We can also call deceleration or decelerated motion. Decelerated motion. So the green is accelerated motion and the red is a retarded motion. Okay. Now, because xt graph x represents displacement, it could be above the t-axis, and we can also plot the graph below the t-axis. Every possible graph is, graph is possible. You can draw the way you want. So look at this graph. Okay, now one more thing. If you draw tangent anywhere on either graph, the slope will be positive or negative. In the red graph, are we going to get a negative slope? Anyway?
No, sir.
No. Slope is always positive, yes or no?
Yes, sir.
Because it is always inclined to the x-axis at acute angle. So no matter which tangent you draw, the angle made with the x-axis or in again confusing angle made with the t-axis here is acute and therefore it is positive slope. Okay. So what is the sign of velocity? So sign of velocity is positive and positive for red as well as for green, right? It is clear.
Yes.
Now sign of A. To find the sign of A, what we do in the xt graph, we check the two consecutive velocity in the progress of time and we subtract. So in the red case, as you move ahead, the value will decrease. So the difference will be negative. Do you realize this? Yes or no? Acceleration is defined as dv by dt, right? So we increase the time and we find the two velocity and we take the difference. So in case of a red line, as you progress, the slope will decrease or increase. Tell me guys.
Slope
in
will
case of-
decrease.
So as the slope will decrease, the velocity will decrease in value, in magnitude, yes or no?
Yes, sir.
So the difference will be what? Positive or negative?
Negative.
So acceleration is called difference of velocity upon time, right?
Yes, sir.
Acceleration is dv by dt. So difference of velocity means final minus initial upon time. So if you do so, final minus initial upon time, what will you get? Positive answer, negative answer?
Negative.
So in case of red line, the sign of A will be negative, yes or no?
Yes, sir.
Whereas in case of green line, the sign of acceleration is positive, yes or no?
Yes, sir.
Now what you need to remember is when the sign of V and sign of A are reverse or opposite to each other, we call retardation. And when we have same sign, we call acceleration. So accelerated motion when sign is same. So if both are negative, it is accelerated. If both are positive, it is accelerated. If one is positive, other is negative, it is retarded because they are opposing each other. And when acceleration and velocity are opposite to each other, then only we call retardation. It is clear, guys?
Yes, sir.
Yes, sir.
Okay. So now the next most interesting one is this graph. Try to decode this graph. Let's say the point P is the point of inflection. Do you remember the point of inflection? Anyone? We have discussed in maths. What is point of inflection? A point where the curvature changes. So it is concave to convex or vice versa. So below the point P, the graph is concave up, and beyond the point P, the graph is concave down. Do you realize this?
Yes.
Yes, sir.
So the curvature is kind of twisting from concave up to concave down. Therefore, that's why the point P is called the point of inflection. And this is the peak of the graph. I will change the sign of the graph and the color of the graph. And for the red one, the P dash is the point of inflection, because from concave down it becomes concave up. So we describe the like this O, P, Q, P dash. That's called Q dash. Now, can we describe the motion for every quarter? You can say O to P, P to Q, Q to P dash, and P dash to Q dash. So what I'll do is sine of V, sine of A, OP, PQ, QP dash. So let me make a table. So this is the most difficult part for you. And once you comprehend this part, then it means you are okay with the cohesion time graph. You can describe, you can understand really good. So OP. In the O to P part, what is the sign of V? And you know the sign of V, we just check the slope. So if you choose any random point between O to P and if you draw a tangent, what do you think? It will make acute angle with T axis or obtuse angle?
Acute.
Acute angle.
So this acute means positive slope or negative slope?
Positive.
So if acute means positive slope, so sign of V will be positive? Yes or no?
Yes.
Very good. So first part you nailed it. Positive. Okay. Similarly, explain the P to Q part and Q, P dash and P dash Q dash. Everyone. So Rugved will tell me P to
PQ
Q.
will be
Yeah, tell me. Rugved. P to Q will be?
Positive.
Very good. Are you like confused or not 100% sure?
No, I'm 100% sure.
Very good. Q to P dash, sure, I will tell you. Okay, Shreya is not answering. Siddhant, tell me, Q to P dash?
So negative.
Negative. Okay, Shreya answered negative. Yeah, so that's correct, Shreya. This is negative. And P to the Q dash, it is also negative. So let's talk about the sign of A. How to find the sign of A? We take two consecutive velocity mentally and we subtract and check whether it is positive or negative. Okay. So O to P. In O to P, if you take two velocity consecutively, one after the other, and if you take the difference, what will happen?
Positive.
Positive. Very good. P to Q.
Negative.
Q to P dash. That's very interesting.
So positive.
Think about it. The value itself is negative, no? So as you progress, the steepness will grow. So more the steepness, more the value. So we have greater negative value. So you can think mentally like -3 to -5. The difference will be, if you go from a small negative to like a small negative, like negative wise, like value wise small to big value, but negative sign, the difference will be what?
Difference will be negative.
Negative.
So,
But P dash to Q dash, you can see the slope will decrease in value. It is negative, but it's decreasing. So it's like -5 to -3. Think this way. Now the difference is positive. How to remember this? So it's very easy. If the value is increasing, it is sign of A will be same as sign of B. If value is decreasing, sign of A will be opposite of V. That's how you can remember easily. Because sign of V we can always find, and you can always see whether it is decreasing in value or increasing in value. So from O to P, we can see clearly the V is increasing. So sign of A must be same as sign of V. So both are positive. You can clearly see the accelerating part will have similar value. Can you see that? And the retardation will have, you can see retardation will have opposite sign. You can see both. So concave up and concave down can have different meaning. So while ascending, concave up is acceleration, concave down is retardation. But while descending, concave down is acceleration and concave up is retardation. Do you realize this, what I said? So while ascending in the graph, concave up is accelerated graph, concave down is retarded graph. But while descending, it is reverse. So if you remember one of them, the other you can recall easily. Is this clear graph? The graph is clear to all of you?
yes. Sir.
Okay. All right. So I'm giving you situation, and what I expect is you will plot the graph. So you all are driving your car with constant velocity. Okay. And then you apply brake till you come to rest. What is the question? So you drive your car with constant velocity for some time. You start from origin, assume it. You drive your car with constant velocity for some time. You apply brake, come to rest. only up to this, you can say duration, plot your xt graph and send it to me. Everyone, do it fast. And assume that when you apply the brake, you retard uniformly. Think like that.
So can you repeat the question?
Let me write down the question. Yeah. This is your question. Siddhant, come on. Constant velocity in xt graph look like? Think about it.
Oh, sorry, sir.
Now, Prasansa, you tell me one thing. If you are driving a car and if you apply brake, will you go forward? Will you go backward when you apply brake? Tell me. What happened?
Forward, but then stop at it.
So when you are stopping, you're still going ahead only, no? Are you coming back?
No.
So check your graph. In that graph, are you going forward? You're coming back also, right? So first you are increasing the x, but you are again decreasing the x. Is it correct?
No.
The position only increase, no?
Yeah.
Are you realizing what I'm saying?
Yes, sir.
Yeah. So rectify this. Rugved, I'm waiting for your answer and share. Okay, you did the same mistake, Siddhant, that share did. I mean, sorry, Rugved, when you apply the brake, you still move forward, no? Yes or no?
Yes.
When you apply brake, you have moving forwards, but you have drawn the horizontal line. Is it correct?
No.
Think about it. It's not easy. Okay, Prasansa. So it's quite close, but you have to think a bit more. Something is wrong. And you know what is wrong? There is a kink you're forming. You know, kink. like a corner. Now corner means what? At that location, there are two tangents, right? It means at one point there are two velocity, which is not possible. Yeah, Siddhant, now you got it right. Very good. And at the topmost point, it will become horizontal, isn't it, Siddhant?
Yes, sir.
It will not come down. So I think you have brought it slightly down, which is not possible. It will stop
Yes,
till
sir.
the
That is
top.
just a
Yeah,
drawing mistake.
yeah, that's understood. Prashant, you got my point? What I'm saying? The kink should not be there. It should be a smooth graph. The transition will occur smoothly. So draw the third one. I hope you'll get the right answer. Rugved, tell me how the retarding graph looks like. You can go back and you can see which of the following is the retarding graph. You can check.
Yes, sir. I sent you one.
Yeah, sent one. Again, you have made the same mistake. There should not be any kink, no abrupt change, a smooth change. Again, person say you're doing the same thing. The change must be a smoother transition. I do not want kink, like nothing like this. I mean, I don't want this. A smooth change, straight and without change of slope, like this. A concave down graph. And it will stop exactly. It will come parallel to the t-axis. This is the graph. Do you realize the graph, everyone? So
Yes.
read the question. It is moving with constant velocity. In case of xt graph, we have discussed that constant velocity represents constant slope. And because you are beginning from the origin, it will look like this. Let's do something like this. For some time. So it is happening for some time. And then you apply the brake, so you will retard. So it will be concave down graph. And there is no kink. It will be a smoother transition like this. And eventually it will become a horizontal line. So I can draw a bit more. That's it. Horizontal means the slope is 0 now. At this point, there is no slope. If you draw a tangent, it will be horizontal. Understood? So your graph will look like this. How many of you realize this?
Yes.
So a concave down is retardation. And this is the constant velocity. Okay. Is this clear?
Yes.
So let's plot something more. So let me give you a situation. You start from rest, you accelerate for some time, and this is the very realistic situation. So you accelerate for some time, and once you attain some velocity, you continue to move with the same velocity for some more time. Okay, and then you apply brake till you come to rest. What I'm saying? Let me revise once again. So situation is very complex. There are three situations. Assume you start from rest, accelerate uniformly for some time, then apply brake and retard uniformly till you come to rest. Now this is slightly difficult situation. So can you plot X and T graph, guys? Everyone, please try. Be very careful. You have to be very careful in plotting this graph. Plot and send it to me. So this graph will have three parts, isn't it? So how many parts you have in this graph? 3 or 2? Siddhant? Siddhant, tell me.
Sir, 2 only. No?
No. You read the question. Just wait, just a minute. I mean, oh, no. This is my mistake. Yeah, your graph is correct. So assume you start from rest, accelerate informally for some time, then you move with constant velocity for some time and then apply brake. So I can do. Just a minute. Let me retype. Your graph is correct. Assume you start from rest, accelerate for some time, then move with constant time. Apply comes to okay. Now change your graph. That graph is correct actually. Okay. Okay. You're trying your level best, but what I will say is just make sure that there is no king. King means, you know what is the meaning of king? A sudden change of velocity. Here nothing is changing suddenly. Everything is changing smoothly. So just make it more clean. Yeah. Okay. Okay, fine. I think. Very good. Very good. With free hand, all of your graph is correct. So try to make it more accurate. Nothing else. Everything is correct. The way yours is slightly feeling the pain of drawing, huh? But that's correct actually. I mean, technically, it's close to correct. So first of all, you all accelerate, right? And you start from rest. So it will look like green graph. And then you continue moving with the constant velocity. So the velocity at this instant will continue. So in a way, the slope will look seamless. And then you retard. And when you retard again, it is seamless. Till you come to rest, it means it will come eventually horizontal. So I think you all have tried to do the same thing. Just with practice, you will get this more clean. If what you can see, I cannot have king here, I cannot have king here, because king means a sudden change of slope, and sudden change of slope means sudden change of velocity, but velocity cannot change suddenly, right? It will take some time to change. Do you realize this? Hello guys,
Yes, sir.
is the graph clear? Okay. In all this journey, you need to understand or realize that you're not coming back, you're going forward and forward. So on the x-axis, it is always going ahead. So when you come to rest, you're coming to rest here. That's the meaning. Okay. I hope this is clear. Clear, guys? Yes or no?
Yes.
Yes, sir.
Now, reading graph is one important skill in physics and mathematics both. In fact, if you want to master mathematics, especially the calculus, you have to be like pro with graphical solution and graphical interpretation. So many a question of calculus we can solve mentally if we can pull out the graph mentally. Okay, so you will learn this thing definitely in maths, but okay, physics will help you in looking at the graphical side more often. So this is the last question from the XT graph. We'll move to the next graph very soon. Today lecture I'll finish early because tomorrow is some sort of puja and all, and then I will be leaving. So your next lecture on Wednesday will not occur. I'm coming back on 4th. So on Friday I'll keep the next lecture. I'll give you sufficient homework for the duration. Now this is the graph of position and time. So let me pull out the graph. You start from somewhere here. You go ahead. You come back to origin. You turn. You go back. This is the end of the journey. Let's say. Okay. So I'll plot the lines. Okay, so the question is find the average velocity and average speed for the interval 0 to t. Okay, let me make it better. 0 to capital T. So you know the definition of average velocity and average speed, right? These lines I have drawn for your understanding. So basically, this is not actually existing. And the coordinates are given to you. You have to read the graph carefully and calculate this answer. This is your challenging question for you. Try this out. Have I shared the sheet from the resonance? Kinematic sheet? Yes or no? If not, I will share the just now.
Done, sir.
Okay, so tell me the average velocity.
Sir, is it x3 minus x1 by t?
It is final minus initial, which is x2. That's it. So final is where? X1, no? You end your journey here, which is x1, and you begin at x2. Correct? At t equals to 0, where you are? At x2, no? So the displacement is called change of position, right? So final position minus initial position is called displacement upon time is called average velocity, isn't it? Do you realize this?
Yes, sir.
So what you wrote? You said something different, right?
Sir, I wrote x3 minus x1, but
X3 minus x1. Why? The
now
journey you
I
have to check.
realized
Yeah.
starts from x2.
So can you find the average speed now? Once you have realized. Anybody else getting the first answer? Rugved, are you getting the answer?
Sir, I also took from X3.
So the definition is important. You need to remember what is the definition of average velocity. It is the displacement upon time, and displacement is defined as change of position. So change means final minus initial. A basic definition would have led to the right answer, but instead I think you just applied something else from your intuition, right? If you have realized the first part, I hope you can also realize the definition of average speed. You need to also
Yes,
remember
sir,
that your motion is along the straight line only. So you're going to and fro only. So your motion is along the x-axis. You're not going right or left, right? So you can count the distance travel, right? By taking the length which you traverse. Yeah, Siddhant, tell me if you're getting something.
is the answer x1 plus x2 by t?
Definitely not. It's not so easy. Distance upon time, right? What is the distance here? How much you travel? If first you go from x2 to x3, so how much you travel? You travel value x3 minus x2. You travel this much, and then you come back from x3 up to origin. So you travel x3 again. Then you go from origin to x2. You travel x2 again. Then you go from x2 to minus x4. So you travel x2 plus x4 again till bottom. And then you go from minus x4 to x1. So you travel x1 plus x4 again upon t. How many of you realize this part? This is the most challenging part. No one, I think. How you calculate the distance? By measuring the length of the path which you traverse, right? So what is happening here? Look at this. This is happening. You are going from here. You're traveling back till here. Now you can calculate easily along with me. Tell me how much you travel value wise.
X3 minus
X3 minus X2. Very good. Then you come back till here. How much you travel?
X3.
X3. Then you go here.
X2.
X2. You come up to here. How much? X2 plus X4.
X2 plus X4. Yes.
Then you go till here. X1 plus X4.
Yes. Sir.
The length of the path is called distance, right? It's not so easy. So the answer is one of the X2 will cancel out. So what I'm getting is 3, 3, 2 times and 2 and 1 and 2 times 4. So you can understand the XT graph is very, very difficult graph, right? To interpret correctly. And it is normal. I mean, I do not expect that you will get the answer at first go. I have seen most of the students, those who get a all India rank below 100, they also don't solve in the very first go. So you need to realize this. So many students have solved this question in the past, but many good students also have not solved. That's not a big deal. Do you realize this question? Yes or no?
Yes, sir.
Very good. Let's try to understand what is the meaning of average velocity in a graphical way. So we'll try to understand a very, very unique concept of average velocity and how we can determine average velocity graphically. See, we cannot determine average speed because for that you need to do the actual calculation of distance. But average velocity can be done directly from the graph. Okay. This is the most important part. Okay. Average velocity from XT graph. So let's say this is the graph, XT graph. This is T1. And if someone is asking you to find the average from T1 to T2, so what you need to do is just join the coordinate at T1 and coordinate at T2. And if this is X1 and if this one is X2, oh, sorry. So if you just connect the 2 points, the beginning and the end point, because I'm looking for the answer from T1 to T2. So what is the displacement here, guys? What is the displacement? What
X2.
is the displacement from T1 to T2? Like for the interval T1 to T2? displacement is? At T1, you are at X1. At T2, you are at X2. So what is your displacement?
The
X2
straight line.
minus.
And what is the time interval? So the average velocity is how much? And if I call this as theta, you can exactly see that this is tan theta. This is tan theta is also the same, right? And you can also see this theta is, this is also theta. So the slope of the secant gives you the average. Do you realize this? You know secant, we have discussed. So average velocity is always equal to the slope of the secant. So if you know the beginning, if you know the end, simply join the beginning and the end, find the slope of that line, and that will be your answer. That will be your average velocity. Is this clear?
Yes, sir.
So this is the most interesting and challenging part for all of you to understand. 5-star. So do you think that you have understood the XT graph, guys?
Yes, sir.
Okay, very good. So I am sending the question. You just need to attempt this question. But for that, I will suggest that you open your SC, or sorry, IRODA book and then solve. Those who don't have, so you have to read this question very, very carefully. Which question? 1.4. So if you have the book of IE IRODA, open it. If you don't have, you can see I have sent the question on your WhatsApp group. So you have to understand the question number 1.4. First, you spend some time reading the question. Try to digest the question. And once you have realized what is happening, try to solve the question. Okay. And you can read the box as a gap. So you can take one box as some unit. So it's easy to read the box. Okay. You have actually plotted such graph as an exercise. So I hope you can realize this. Okay. So that's why we did this experiment, plotting the graph. So take your time. Don't bother. Graphical skill is very, very important skill if you want to write the Olympiad or particularly JEE advanced, because in JEE advanced they generally ask the graphical based question, at least 1 or 2 questions every year, sometime more also. So an ability to interpret the graph is very important. In most of the American universities or any Western country, in the school curriculum, the graph is actually most important part, because they do actual experiment. They go in a lab, they prepare the actual worksheet, they try to put the real values of experiment, they plot it actually, and then they from there they learn the meaning of graph. So they have more importance on the graphical way of learning, or you can say the lab based or experimental learning in science than theoretical learning. So Indian students are good with the theoretical understanding, and the Western counterpart are good with the experimental. That's why they are able to create new machinery or devices easily and we are good with the publishing the research paper with theoretical nature. So when you go, in a higher studies, the lab will become more important than theory. So here we are plotting like this. They have always the graph paper always attached in their notebook itself, and they have a lot of question of graph.
So we have to solve these questions now.
No, okay, let me give you homework because now I'm leaving the class. Okay, so today lecture I'll keep it short, and we all are going to meet after 3rd of November. So your next lecture will be, so the Wednesday is on 3rd, right? Let me just check the calendar. Okay, yeah, Wednesday is 2nd, na? So your next lecture will be on 4th, Friday. So I have shared some sheet with you. Of course, I haven't taught you all graph. I have just taught you one single graph, which is XT graph. So you try to attempt the basic question that we have learned so far, and then the graphical question, whatever you can understand and solve. Okay, so I'm not restricting that you should solve this or that. You know the basic. You have to think about the slope and think about the area, interpret it and get it. Although I'm going to cover everything in detail, but because this is a long weekend for you, you can attempt all those questions. You can send me the doubt on WhatsApp because generally the network in my area is very weak. I can read the WhatsApp, I can reply. Okay. So see you guys on Friday, and we'll do more aggressive lecture from Friday onwards. Bye and take care.
Basi, thank you.